Okay, we have 12 more minutes, so let's talk about circles. And we're not going to get all the way through circles, probably. Maybe we will. Let's see. If you have your piece of string, I'm waving a piece of string in front of me, but you don't have to see it because you know what string looks like. Then take out your piece of string. And this would be more fun if we were all sitting together in a classroom and someone could be an embarrassed guinea pig as we wrap string around them. But we can just do this at home if you want. So if I hold out my arm straight in front of me, let me turn off my screen share. So I'm going to hold out my arm. I have my string, and I want to wrap it around my arm like I'm taking my blood pressure. And I get how long it is to go around my arm. And my question is, if I was to just measure the top and bottom of my arm, like in the picture on my screen, then how many of these, the distance through my arm, if you were to stab me, would it take to go around my arm?
2.
And if we measure it out, then it gets to be roughly 3. So how many of the through distance does it take to go all the way around? We could also do the same thing with our head. You could wrap your string around your head, see how long that is, then sort of measure the distance through your head from ear to ear by holding the string in front or behind of your nose or behind your head. And then how many distance from ear to ear does it take to go around your head? Everyone understand the question we're asking?
Yes.
Now, measuring our body makes it entertaining if we were all in the same room, but it doesn't really tell us anything about math because these are supposed to be real circles and our arms and our heads are not actually circles. But if we were to do this with real circles, we would always get the same answer. So first we have some extra words. The width of the circle going through its center, so this ear-to-ear picture above, that width, that length is called a diameter. And I don't know why somebody made up this word because width already was a perfectly good word, but diameter is just width for circles. And the perimeter of a circle is called circumference. And again, we have a perfectly good word, perimeter, for how much the ant walks around the edge of a shape. I'm not sure why we need another word, but there it is. We have to use it. It's circumference. So the question is, how many diameters make up a circumference? Or how many widths make up a perimeter? If I was to take a string, this orange string, through the middle of the circle and lay it along the edge of the circle, how many times would I have to do that before I get back to where I started? And when you try it, you always get some number a little bigger than 3, but a little less than, but a bit less than 4, much closer to 3 than 4. And if you haven't, I would urge you to try it. So on the screen, hold up your string, or after class, take a circle. So make it so one of these actually fills up a significant part of your screen. Take your piece of string, and here, I will stop my share. So I'm going to actually take my string, hold it over the diameter, say this is the diameter, and then try and put it around the circle and see how many times I go around before I get back to the beginning. And it's a little bit more than 3. Okay, share my screen again. So, oops. The answer to that was important to the ancient Greeks, and it's important to mathematicians ever since. But the ancient Greeks were the ones who got to name it. So they named it with their letter pi, also written as pi. And this is different than the formulas we've done before. we had the rectangle that was area equals length times width, and that was a definition. That was just how we defined square units of area. We weren't figuring anything out. Then we did some figuring. What's the area of a triangle? What's the area of a parallelogram? What's the area of a trapezoid? Now we are back to just a definition. When we say circumference is pi times diameter, that's just defining pi. Pi is the number of times that you take the width of the circle, ta-da, and when you unroll it, it takes to wrap around the edge. So this is a formula. Circumference is pi times diameter, but like area is length times width for a rectangle, it's just defining the pi. It's not figuring things out. What's amazing is that pi shows up not only there. I mean, we know there has to be some number, which is how many widths go around a circle. So the fact that there is a number and somebody once named it is not surprising at all. But if that same pi answer shows up other places, then that's more notable. So here we have a box, and I'm labeling the edges R. You'll find out why in a moment. So the area of this box is R times R, which I'll write as R squared. Everyone with me just for this top box on the screen?
Yeah.
Okay, now I photocopy the box. So I have 4 copies of the box in the middle picture, and the area is 4 R squareds, because there's 4 boxes, and each is an R squared. Everyone okay with the middle picture?
Yeah.
So now I'm going to ask a question, which is the bottom. If I draw the biggest circle I can in that box, now I can see why I picked R, because the radius of this circle, that's half the diameter, starting in the middle and working my way out. I should write that also. So let me move this to a Jamboard. So this distance here so that's the radius. So I'm going to draw a circle, and I can name it. It's the circle with that radius. How much of the brown box does it cover? Not all of it, because there's these little wings sticking out. But how much of that brown box does it cover? Does it seem reasonable looking at it that the answer is a little bit more than 3/4?
Yes.
Yeah, it's more than half, but yeah, sort of 3/4-ish. By the way, why do we have diameter and radius as 2 different words? It's because if you are given a circle and asked to measure it, it's easiest to take your string or tape measure and go all the way across. You don't have to find the middle. Does that make sense? So if someone else made the circle, then diameter is what you want to work with. Whereas if your job is to draw the circle, then it's easiest to take a piece of string and say, I'm going to fix one end of the string to the table and draw with the other end of the string and make the circle that way. So if you are the circle artist, then radius is easier for you. So that's why we have both of them historically. Okay, whoops, no, wrong one. So there's your definition. Radius is half the diameter. And it looks like it covers about 3/4. And the answer is that it's not 3 of the boxes, 3 of these 4 R squareds. It's actually pi of them, that same number that's a little bit more than 3. So the area of that circle here is a little bit more than 3 of those r squared boxes. And again, that's a formula we can use. We could plug in the radius, square it, multiply by pi, and get the area. But it's also just sort of a definition that it works out that pi is how many of those r squareds it takes when you put a circle on top of a box. It's great that pi is the answer to both of those circle questions, because otherwise we'd need another calculator button, one for using circumference and diameter, and another for using area and radius. But we get the same button for both. And we're not going to have time right now because it's time to go for any example problems, but we'll plug things into these circle formulas. It's also true, you may have noticed, we haven't done lots of example problems with these. And that's okay. So Wednesday's theme will be to take all of these formulas we've learned today and actually plug things in and do lots of problems. So hopefully by the end of today, things you already knew, like 1/2 base times height, now make a lot more sense. And you're ready on Wednesday to start plugging things into these.
Thank you.
You're welcome.
Thanks, Dave.
Okay, feel free to go. I'm going to stop the recording. If you have any last minute questions or want to look at your achievements with me or something,